Good day, Math SL students. Alright, section 4.6, which we're beginning now, is about properties of logarithms. We're going to have two goals that we're going to look at in this video. You see the first one being written on your screen right now. I'll let it get there and then I'll explain it. One of those goals is that you're going to use properties of logarithms in order to write multiple logarithms. Yeah, there should be an M right there. Multiple logarithms as a single logarithm. If that doesn't make sense yet, it'll make perfect sense whenever you see the types of problems that we're really working on. And the second goal is the opposite of that. We're going to learn to take expressions with single logarithms and write them as multiple logarithms. All right, you'll use properties of logarithms There we go. That's what I meant to do. You'll use properties of logarithms to write single logarithms as multiple logarithms in an expression. Very good. So let's get to it. There are three properties of logarithms. Actually, there's a fourth that we could throw in, but it's really, well, let's just stick with the three. Three properties of logarithms that we're going to be discussing. And those properties, or those laws, as your textbook calls them, have names in other textbooks. And I'm going to go ahead and refer to those names here because it kind of helps you remember the properties a little bit. There's a property called the product property, the quotient property, and the power property. All right, now you should be fairly familiar with these properties. Let's go ahead and talk about the product property. What the product property is a way of writing the logarithm of a product, AB, as an expression with multiple logarithms. All right, if you ever have the logarithm of a product, AB, turns out you can write that as the log of the first factor of that product plus the log of the second factor of that product. All right, now this actually works two ways. You can separate the factors of the product to make two logarithms, or if you have the sum of two logarithms with the same base, these are both base 10, if you have the sum of two logarithms with the same base, you can write that as a single logarithm if you just multiply the indexes of those two logarithms together. All right, then the quotient property is kind of the opposite of that. It's called the quotient property because it tells you what you can do with the logarithm of a quotient. All right, quotient being a division problem. If you have a logarithm of a quotient and you want to write that using multiple logarithms, then you can make it log A, the logarithm of the dividend, minus log B, the logarithm of the divisor, or numerator, denominator, whichever way I want to look at it. I could do that, or if I have the difference of two logarithms with the same base, I can rewrite that as a logarithm of a quotient of the index of each of those other logarithms. All right, then there's the power property. And the power property tells you what you can do if the index of a logarithm happens to have an exponent. So let's say we have log of b to the nth power. What you can do if you have a logarithm where the index has an exponent is you can make that exponent into a coefficient for the logarithm, move it to the front of the logarithm, and express that logarithm as n times log b. Or you can go the other way, and if you have a coefficient in front of a logarithm, you can simply move that coefficient and make it an exponent for the index, like so. Those are the three properties that I need you to know, and I'm going to show you several examples of problems that you're going to use those properties in order to answer, I suppose. All right, so let's take a look at some of those. Here, our directions are to express each of these logarithmic expressions using a single logarithm. All right, so remember the power property, product property, and the quotient property. If you already know what you're doing, pause the video, try these examples on your own, and just use my work to check yours. All right, if you don't know, watch these two examples. I got a couple more with the same skill in a moment. All right, you're going to notice that we have two logarithms, both base 10 logarithms, as it turns out. Most of the ones in this video are. And we're trying to find the difference between those two logarithms. Well, if we want to write that as a single logarithm, that means that we're going to be able to use the quotient property. And when we use the quotient property, we just take the indexes of those two logarithms and divide them. So you get the log of 42 over 6, and of course you simplify it to become log of 7. Very easy, right? All right. Now you're going to notice in part B that we have the sum of two logarithms with the same base. And so we're going to end up using the product property. But before you're allowed to use the product property or the quotient property, you have to make sure that a logarithm does not have a coefficient. If it's got a coefficient, you cannot apply the product property. So we're first going to have to use the power property to rewrite these expressions so that those coefficients become exponents. Then once we've done that, we can use the product property. Alright, so 5 log x is going to become the log of x to the 5th power. And then we'll write our addition sign. 2 log y is going to become the log of y to the 2nd power. And now we have a sum of two logarithms, and neither logarithm has a coefficient. They both have the same base. We can then write that as log of x to the 5th y squared. Make that sum of two logarithms into a logarithm of a product using the product property. Good. I want you to try this next pair of examples on your own. You've seen what you're doing at this point. Make sure you follow order of operations with those parentheses. Try it. Now you're going to see that we've got a subtraction problem here, so we're going to use the quotient property at some point, but inside of these parentheses we've got a sum, and we've actually got a coefficient as well. Okay, well let's take care of what's in the parentheses first, and I think you'll understand what I do if I kind of use the product property and the power property at the same time here. Not doing anything with the ln of a yet, but I'm going to combine what's in the parentheses into a single logarithm. Now that's going to end up being b times c to the 4th power as the index of this logarithm. See how that works? Made this a coefficient, and then I multiplied the two indexes together when I made the single logarithm. Alright, then finally let's go ahead and take care of that difference of two logarithms and make it into the logarithm of a quotient, and that quotient would be a over bc to the 4th power. You doing well so far? I bet you are. Alright, now the next one. Hope you didn't try to use the product property or the power property or any of that junk, because there is no way to simplify. Cannot simplify. Do you know why you can't simplify? As soon as I finish writing you cannot simplify, I'll tell you. The reason you can't simplify that into a single logarithm is because of the bases. The bases are not equal. These properties only apply if you're trying to combine logarithms that have the same base. Great. Let's do something a little bit different, put a slight spin on this whole thing. This time what we're going to do is we're going to look at expressions that have multiple logarithms but only numbers. And we're going to try to use properties of logarithms in order to be able to find the value of that expression. And they're each going to work out to be integers. Now this is something I want you to do without a calculator. If you have a calculator, it's easy. You just type this in plus that and so forth. It's great. But let's see what we can do without a calculator. Alright, part A. You see we got the difference of two logarithms, and the second of those logarithms has a coefficient. Let's take care of that coefficient first, and let's make this log base 6 of 24 minus log base 6 of 2 squared. Now 2 squared, of course, is going to give you 4, so let me just go ahead and write 4 right there. Then we can use the quotient property, divide 24 by 4, you get 6. And now this is a very simple logarithm to evaluate. We're trying to answer the question, what power of 6 gives you 6? And that's of course 1. Make sense? If so, try the next one. A little bit tougher, but definitely something you can handle. All right, I'm going to begin by using the power property in a couple different places. You see coefficients for 2 of the 3 logarithms here. For the first one, we've got log base 5 of 16 times 1/2. So we're going to end up having 16 to the 1/2 power. Now, you could go ahead and write what that is, but since we don't use those fractional exponents overly much, I'm going to go ahead and write that this way. That means we're going to end up with log base 5 of the square root of 16, doesn't it? Because that's what 16 to the 1/2 power is. And if you realize that that's log base 5 of the square root of 16, then you understand why we can make that log base 5 of 4. All right, and then we have another log base 5 of 4 right here. And then we're going to subtract log base 5 of 100 because 10 squared is 100. All right, I'm going to try to do 2 things at once here. Should work out quite nicely. All right, I tell you what, my apologies to those of you that have already started this example on your own. I want that second log base 5 of 4 to be a log base 5 of 5 instead. It didn't work out where we got an integer answer, and I need that to be an integer answer. So let's change that here, and let's change that here as well. All right, and then, whoops, well, that wasn't changed, was it? Now let's continue. Okay, so we're going to use the product property, and we're going to make that log base 5 of 4 plus log base 5 of 5 into a log base 5 of 20. All right, then use the product or the quotient property, excuse me. And let's go ahead and simplify the fraction that we're going to get right now. You're going to get 20 over 100, right? All right, 20 over 100, and 20 over 100 is the same thing as 1/5. And when you write it as 1/5, now I think you can see the value that we're going to get for the logarithm. What power of 5 gives you 1/5? It'd be -1, wouldn't it? All right, there we go. Got a couple more examples that I want you to look at in this video. Let's go ahead and get there. And this is going to be involving our second goal, which was basically to expand logarithms rather than contract them into a single logarithm. The directions here, kind of weird for right now. You will understand completely what to do with them momentarily though. Given that some value p equals the natural log of a, q equals the natural log of b, and r equals the natural log of c, I want you to find an expression in terms of p, q, and r for the natural log of a, b over c. Now the basic goal I have for you here is for you to expand that expression so that we only have things that are either ln of a, ln of b, or ln of c. Because as soon as we have that, then we can replace ln of a with p, and so forth. All right, now you're going to see this logarithm has 2 things going on. It's got a quotient, the quotient of ab with c, and then it's got a product as well. Let's see what we can do then to expand it. All right, first I'm going to separate that quotient. So let's make this the natural log of AB minus the natural log of C. Then let's separate the product right there by using the product rule, and that will become the natural log of A plus the natural log of B minus the natural log of C. All right. Then finally, the ln of A is equal to P, the ln of B is equal to Q, ln of C is equal to R, and we want our expression to be in terms of P, Q, and R. Well, let's go ahead and substitute then. The ln of A is P, so we got a P and then plus a Q and then minus R. That's what we're trying to do right here. 2 more examples of this. If you already understand, go ahead and try this on your own. If not, watch the next one and then do the third one on your own. Alright, you know that you're going to start off by separating the quotient, so that's going to give us the natural log of the square root of a minus the natural log of c to the fourth. Now this next part's a little bit tricky if you're not thinking fully. How in the world do we get rid of a square root of a that's within a logarithm? Well, square root of a is the same thing as a to the 1/2 power. So I could write this index in exponential form, and it would have 1/2 for an exponent. But then I can also bring that exponent to the front, can't I? So I'm going to say that that's 1/2 times the natural log of a minus, and then I'm going to go ahead and bring this exponent to the front and make this 4 natural log of c. Now the reason I wanted to bring those exponents and make them coefficients is because I know that the natural log of a is equal to p. I know the natural log of c is equal to r, but I didn't know what the natural log of the square root of a or of c to the fourth was. Alright, we're now going to make this 1/2 times p minus 4 times r. Great. Try the third one. Now the question you might have on this one is what you're going to do with the 3. And what I'll tell you to do with the 3 is just hold off onto that in the end. Just write 3 and then let's expand the logarithm in brackets. And I want to see if you can understand how to expand that logarithm in almost one step anyway. You see that we've got this product right here, and then we've also got a quotient going on. Well, to separate the product, we're going to make that a natural log of b squared plus the natural log of c, and then we'll subtract the natural log of a. Make sense? Then let's go ahead and bring this coefficient down and make that a 2 ln b plus the ln of c minus the ln of a. Alright, finally, well not finally, we're going to have 2 more steps I guess. We can now go and substitute q, r, and p into this expression. So we're still going to have a 3, but instead of 2 ln b, we'll write 2q plus r minus p. And then finally, we can go ahead and distribute that 3 to each of these terms here. And we'll get 6q plus 3r minus 3p. Alright, thanks for your attention. Hopefully this properties of logarithm stuff is clicking with you. Good luck with it. Let's try some more in the next video.